In Onslaught, the number one point of player feedback I've gotten is that controller aim felt bad. But how do I make it feel good? In this video, I'm gonna figure out why it's so difficult to aim, and how to change it to be smooth and intuitive. So, as usual, I started up a new project in order to isolate and fix the aiming. This is a super useful thing to do, because then I can make tweaks as needed without having to worry about working around a large codebase. To start, I copied the old aim system into the project, that way I have a reference to how the game's aim feels currently. I also added this moving dot so I can try tracking a target with each refinement of the aiming system. Now that that's all set up, I can finally start making some code changes. The first thing I knew I needed to fix was the deadzone problem. Controller sticks have a horizontal and vertical axis. I'll start by just showing the horizontal one. Depending on how far you move the stick, it outputs a value for each axis. 0 being the stick isn't pushed at all, 1 being the stick is pushed all the way to one side, and -1 being the stick is pushed all the way to the other side. A dead zone is the amount you can move the stick on a controller without the input being registered, indicated by the red lines. So you can see what I mean, let me show you this red dot. The red dot is the controller's raw or unmodified value, and the white dot you see is actually the modified or deadzoned value. I can move the stick as much as I want within the range of the dead zone, but it won't output anything. This is useful because sticks on controllers don't snap back to exactly 0. The better your controller, the closer it gets to 0, but no controller is precisely perfect. If you've ever experienced stick drift, or a game detecting a stick input without you actually touching the controller, then you'd need to check your game settings and increase your controller dead zone so that the stick, when untouched, will return to 0. Older heavily used controllers especially have this problem because the hardware gets worn down. And here's where the deadzone problem comes in. Unfortunately, because dead zones filter out horizontal and vertical inputs less than a certain amount, it causes your aim to snap slightly to the 4 cardinal directions, or directly up, right, down, or left. The higher your dead zone is, the more noticeable it is. Once the axis value is below the dead zone, it stops at 0 for a while before you get past the dead zone on the other side to continue the movement. So, in order to fix this, my plan was to completely remove the dead zone when you're aimed in, that way it's smooth. But it isn't that easy, because GameMaker's built-in dead zone function doesn't allow you to change the dead zone of sticks individually. If I'm shifting the dead zone for the right stick, I don't want to also change it for the movement stick. Then when you're aimed in, it would cause stick drift on your character's movement. So you know what that means, it's time to make my own dead zone function. Now, controller dead zoning doesn't just filter out small inputs. No, that would be far too simple. It also normalizes the output value. Normalization is outputting a number between 0 and 1 based on a value between a different range. What this does is that it guarantees that you will get a smooth value from 0 to 1 regardless of your dead zone. In order to implement this, let's first make a normalization function. Searching it up, we find this formula. We need to pass in the value to be normalized and the range that the value should be normalized to. Now we can return the formula calculation using the variables we passed in. And let's also add an optional parameter that will restrict the value to be between 0 and 1. Now that we've created a normalization function, it's time to make the function that returns a deadzoned axis value. GameMaker has a function called GamepadAxisValue, where you pass in the device ID and the axis to check. We want our function to do exactly the same thing, except we also want a deadzone parameter. I'll call this function GamepadAxisValueDeadzone. First, we need to get the raw axis input. Now we can normalize the raw value between the minimum range, which is our dead zone, and the maximum range, which is 1. Then we can return our deadzoned value. It's important to note that the raw axis input is a value between -1 and 1, because you can move the stick to the left, which returns -1, and to the right, which returns 1. But we need to normalize a value between 0 and 1, not -1 and 1. To fix this, we just need to remove the negative sign by getting the absolute value of the raw input. Then, after we finish our normalization, we can return the normalized value multiplied by the sign of the raw input which effectively puts the negative sign back on if it was removed by the absolute function. Now, instead of using gamepad axis value to get the distance and direction vectors, we can use our new gamepad axis value deadzone function, which allows us to use a custom dead zone for individual calculations. With this newfound dead zoning freedom, my first iteration of the new aim system was to simply remove the dead zone entirely when you're aimed in. This did fix the angle snapping issue, which already feels better, but the aim still feels clunky and shaky. Maybe when you fully aim in, I could lower the speed at which the weapon rotates. That might fix it feeling shaky. Nope, that definitely didn't work. Now it not only feels clunky, but also incredibly inconsistent. It was then that I had a sudden realization. My current approach was flawed to begin with. The current aim method rotated the weapon to face the right stick's direction, and the cursor snapped to a fixed distance away from the weapon's direction. Of course you're going to feel a disconnect. You think that you're controlling the cursor, you're focusing on the cursor, when in reality you're controlling the weapon itself. Instead, you should be controlling the cursor, and the weapon rotates to follow the cursor, just like with mouse movement. It's so simple! So, with the goal of making controller aim feel more similar to mouse movement, I started making changes. My fingers typed. No, danced. No, flew! Across the keyboard as I typed the code, painting the canvas that was the screen with my code that was the paint, willing the ideas from my overflowing mind into existence. First, I made the cursor lerp to the target position of where you aim, and the weapon points towards the cursor. Because the cursor lerps towards the target point instead of jumping there instantly, it feels much smoother. Then I made the cursor move closer or further away from the player, depending on how far you move the stick. This significantly helped the aim to feel more directly connected to the controller, making it feel so much more natural and intuitive. However, because now I was using the distance and not just the direction, I needed to gradually shrink the dead zone as you move the stick further away, as opposed to immediately setting it to 0. It was tough to get this feeling right, but after many small tweaks, it finally feels pretty accurate. With that, my new controller aim system is complete. It feels so much better than the old iterations. Now all that's left to do is implement the system back into the actual game. Or so I thought. And with that, I've finally implemented the new controller aim everywhere. Man, it feels so good to commit a bunch of stuff at once to source control. Boom. Let's go. This is the part of the devlog where I should say things like, it's all implemented into the game, and everything works flawlessly, and go wishlist Onslaught on Steam. Actually, you should go do that last one. But everything didn't quite work flawlessly. After I'd finished implementing the new controller aim back into Onslaught, I was coding this visualization program that you saw earlier, preparing for making this video. But as I was playing around in the program, I discovered some bugs in the code I originally thought worked perfectly. Why does the value not normalize properly when you're aiming diagonally on a higher dead zone? And why does changing the dead zone reduce the maximum distance the stick can move? And, hold on, why can't I ever get right next to the dead zone circle on a diagonal, even though it works either horizontally or vertically? But then, I once again had a sudden realization. Look at the horizontal and vertical axes here. That red line is the dead zone that's applied to each axis. But hold on, what if we put those axes where they go inside of the circle? You can see that those dead zone lines actually make a square. And sure enough, the smallest movement I can make diagonally lines up perfectly with the corner of the square. The circle I showed earlier was actually wrong. I've been applying the dead zone to each axis first, then basing the resulting vector off of those individually normalized axes. In order to actually make it a circular dead zone, I need to get the raw input vector, then normalize the vector itself. This should avoid all the problems with the diagonals, because the vector's length is the same no matter what direction it's pointing. Let's write this function now. We'll call it gamepad get stick vector dead zone. We'll pass in the device ID to check, whether we want to check the left or right stick, and the dead zone level. First, we'll get the raw horizontal and vertical axis values. Then, we'll get the stick direction based on the raw values, which actually fixes the problem of the aim direction snapping to each cardinal direction, without needing me to gradually reduce the dead zone over time. I honestly have no idea why I didn't think of this earlier. This solution is much simpler and much more accurate. Next, I'll get the stick's raw distance from the horizontal and vertical axis, then normalize it to be between the dead zone and 1. Then, if the dead zoned distance is greater than 0, I'll return the direction and distance. Otherwise, I'll return the default output vector. And wow, I thought that it was good before. Now it actually works perfectly. This time, it actually has a circular dead zone and properly normalizes no matter what dead zone or angle you're at. It feels phenomenal, without the inconsistencies that were there before. And now, let me just implement these changes back into Onslaught. There we go. Aiming has never felt better on controller. Almost tempts me to main controller instead of M&K. Anyways, thanks for joining me on my journey of making controller aim smooth. It ended up being a super interesting problem to fix, with a lot more twists than I expected. I learned a lot through this process, and I hope you learned something too. Remember, in any project, making mistakes and running into problems is part of the process. If you persevere, you'll reach greater heights than you previously thought possible. Thanks for watching.